This woman is the mother of mankind, the genetic Eve from whom we all descend. She lived 150,000 years ago in East Africa, and everyone on Earth is related to her. Her daughters and granddaughters will take modern humans out of Africa to populate the rest of the world, the most incredible and important journey mankind will ever make. Genetic tracking for the first time gives us a route map of our journey. With it, we can follow our families of Eve as they travel through an empty world, overcome hardships, separate, and go their different ways to discover new lands. It tells for the first time who we are and where we come from, the most profound questions that have troubled mankind since we first raised our heads and looked at the stars. This new science is a breakthrough. Every one of us can now trace our part in this incredible story. We took samples from these people in Chicago. Our genetic testing will show them how their ancestors traveled the world to reach this destination. One 150,000 years ago, the world was in the grip of an ice age. The ice caps have advanced. Sea levels dropped 400 feet. North Africa is a vast desert with small islands of green. On these islands are tiny groups of people. We are the same people they were. The brain that first thought of chipping stone tools also took us into space. They are hunter-gatherers living in widely scattered groups, roaming each year over great distances, sheltering where they can, gathering seeds and fruit. But to understand who we are and where we come from, we must look at our genetic heritage. Genetic Eve, the woman from whom we all descend, was not the only woman living at the time, or even the most fertile, but her mitochondrial genes were the most successful and the only ones to survive. Everyone alive today can trace a common ancestral line back to this one woman through a unique part of our DNA, mitochondrial DNA. DNA, the blueprint of life, is our own molecular pin code and uniquely identifies each of us. Mitochondria are tiny structures found inside nearly all human cells. It is separate from the normal chromosomal DNA that dictates our height or the color of our eyes. Men inherit it from their mother, but they can't pass it on. In women, it carries on from mother to daughter, down the endless generation almost unchanged. And this is how we can trace our way back to our genetic Eve and her daughters. So written within it is the history of the world's women, and therefore the human race. Professor Rebecca Kahn was the pioneering scientist who uncovered the first all-important clue.
I started working on human mitochondrial DNA so that I would have some kind of view that was objective, that would help me understand and help other people understand how humans around the world were related.
With this new science, she could. Harmless mutation happens all the time in some part of the mitochondrial DNA, leaving minute markers at every change. These markers are like barcodes and can be read in the same way. Kahn and her team discovered the changes happen at a fairly constant rate. They found the groups with the earliest markers were the Africans living inside Africa, and wondered if they might be the oldest people in the world.
I was very excited when I first started to get evidence, and it was so counterintuitive. I'd put 20 Europeans and 20 African Americans on a sheet of X-ray film, and every African American showed differences, and all the Europeans looked the same. As we got more samples from different areas, I realized that it was a difference in the pattern, and that this whole new type of evidence based on mitochondria was going to change the way we thought about modern humans.
In 1987, Kahn and her colleagues published a paper showing for the first time that the markers stretched back to Africa, showing quite clearly that this was the birthplace of the human race. New Guinean tribesman, Parisian bartender, American teacher, Polynesian farmer, all were improbable relatives linked through one black woman 150,000 years ago. Their findings caused a sensation.
The responses of people were sort of amazing. The public was genuinely interested in certain aspects of it, but there was a tendency to misinterpret the data because of the terminology used to describe this woman, African Eve. And people thought it meant the biblical Eve, the single woman in the Judeo-Christian Bible, the wife of Adam.
Her work is rewriting human history. Through it, we now know the first mutations took place in Africa, maybe 150,000 years ago, and belonged to our genetic Eve. Professor Christopher Stringer, Britain's leading paleoanthropologist, was involved in the dating of the earliest modern human skulls.
This skull is as close as we can get to what the face of mitochondrial Eve would have looked like. It's a very complete skull found in sediments in a cave dating from about 120,000 years ago. And we can see here that it's a modern human. We've got a high rounded vault to the skull, a face that's tucked in under the cranial vault.
And this is what she looked like. Using forensic reconstruction techniques, muscle and flesh have been added to the skull and provide us with the very first glimpse of how our genetic mother might have looked 150,000 years ago. This is our new Eve, our new family, direct descendants of the daughters of original genetic Eve now living on the coast, surviving on the harvest of the sea. Our entire survival has always been at the mercy of the climate. When times were good, we could spread out. A bigger range meant more food. But the Ice Age froze the world, and the deserts closed in, forcing our groups into smaller territories, huddled against the coast. Their beachcombing diet consisted of fish,